My name is Dominique Faulkner. My field of study is digital maker and fabricator. I'm currently in my junior and senior year at the University of Advancing Technology. We are going to run through my boards and degree overviews. As you can see here, we have the digital maker and fabrication degree objective overview. We'll go ahead and start with our first one, which is to demonstrate the ability to prototype, build, and apply for patents for technology products meeting specific human factors, form, and function criteria. We will begin with the patent portion of this objective. As you may know, there are many steps to being patented. The first step is to have an idea or a creation that you feel is worth patenting. Here's an idea, something that's an idea that may be worth patenting one day. The second is to search the USPTO website. This is to make sure your patented idea has not been patented already. The website will also give you directions on how to further pursue your patent. I would go to a patent attorney in my case. The amount of jargon and the paperwork just is not my strong point. Plus, the patent attorney will do a patent search as well. This will ensure that your idea is truly unique and worth filing a patent for. Utility patents are what the tech and robotics fields mainly apply for. This is due to the utility patent covering two types of subcategories: the process patent and the products patent, both of which there is more information on in this webpage and online. Prototyping and building is the next stop. In this example, I was asked to build and prototype my off-the-cuff idea that solved a human problem. In this case, I wanted a knife guard that did not have to be removed or put on. It could be washed with the knife potentially and save fingers along the way. As the pictures show, this build and prototype came out decent for a version 1 with no SolidWorks experience. Regardless of the outcome for a V.1, this project shows my ability to apply for patents as well as my ability to build and prototype. In case you're thinking it, this was not the only version of this project. In Objective 2, I will demonstrate my ability to evaluate trends in design principles and apply them into the form and function of devices. Noticing the trends around you can inspire your design. Material, structure, function, form, these are all elements of design. In one way or another, the constraints of these elements will limit your design capabilities. In one team project, the form and function of the design had to be just right. The photos in this slideshow are the progression of my design, the prop arms in this case. The second team project shows there are times that functionality of a product or idea may overcome the form. In this case, the drone base ended up looking out of this world, but the functionality was all there. Objective 3. In Objective 3, I will demonstrate my ability to evaluate material and build technique options during the creation of products and their prototypes. Knowing the materials you use will save you a lot of heartache and probably save lives. The structure is not a new concept. Integrity, shear, strength, melting point, melding temperature, and more. The more we know about a material, the better. Do not build anything for anyone without knowing the limits of what you have made. In that same conversation is the techniques in which we build with. There are more techniques than I can count. From handmade to man-made and robotic to autonomous, there is a certain way to build certain things. CNC machines and lathes are just a few techniques in the tech sector. Bricklaying and roofing have their techniques as well. Objective 4. In Objective 4, I will demonstrate the ability to evaluate and implement developments within electromechanical, algorithmic, robotic, microprocessor, sensor, and other advancing technology areas while making product design decisions. Electronics and logic controllers have been in my life since I wired my first stereo. That said, there was much to learn. The addition of algorithms, code, and sensor tech has made me appreciate the beginnings. Robotics and electromechanical projects are where I love to be. The entirety of mechanical movement from an electrical source is still fascinating. As seen in this objective page, there are many different ways all these industries come together. Electric motors powered by a microcontroller or a motion sensor that senses intruders. The applications are endless. The art of coding a microcontroller is not the newest tech on the market, but it is evolving daily and making what was impossible, possible. Objective 5. In Objective 5, I will demonstrate the ability to work within a Maker Studio environment to design, build, test, and revise products that meet clientele timeline, design, and quality requirements. The Maker environment can look very different depending on the studio's prime objective. In some cases, you will find maker spaces with almost all of the equipment to make anything you want. From designing to testing and revising, the Maker environment uses many tools. Plasma tables, 3D printers, laser etchers, microcontrollers, and multimeters are just some. There is no tool that is obsolete to an open-minded maker. Through a process of prototyping, you design your project on the computer using software. That software outputs a usable code for the machine. The machine and you build the project. You test the build fails in one area or another, and the process begins again. Welcome to the Maker environment. Objective 6. In Objective 6, I will demonstrate my proficiency with industry-accepted prototyping, modeling, build, maker tools, and techniques. The ultimate proof of proficiency is in the website. With the background in the military, electronics, and computer literacy, I was able to pick up on most of the concepts quickly. I have been a fabricator, modeler, builder, tester, reverse engineer, and jack of all trades. The problem has never been that I did not have ideas. The problem was that I had no clue how to truly make them a reality. Through UAT, I've been fortunate enough to learn SOLIDWORKS, Fusion 360, Arduino, 3D printing techniques, Python, and so much more. The tools and techniques learned are shown in the work. Being able to walk through a shop or screen printing business and knowing that I have the ability to use that machine with little direction and confidence should be proof enough.